Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems. Hey everyone, Patrick McFadden. I'm live in London for the Distributed Data Show. Today I'm here with my colleague Alice. You've never been on the show, so introduce yourself.
Okay, sure. I'm a principal architect. I've been with DataStax for about 3 years now, just over that. And I work primarily in the EMEA region, so Europe and UK, of course, and all this area. And I work as a post-sales consultant, and I'm part of the professional services team.
So you get to see a lot of trouble, huh?
I get to see a lot of trouble, and I get to solve a lot of trouble, or at least attempt.
So Roberto's laughing. Did you bring some trouble today?
Probably.
No. So why don't you introduce Roberto?
Perfect. So Roberto is working with a customer that I'm working with, and he's a consultant from a company called EPAM. And please.
Yeah, sure. Thanks for having me. So yeah, my name is Roberto, and I have been working with DataStax just recently for the last probably 6 months.
Yep.
4 months. It has been a very interesting experience, and we were laughing because we have gone through a lot of pain, but also I think that there is a lot of satisfaction for what we have been seeing lately.
Well, I mean, this show is, we're supposed to be talking to engineers, and so everybody knows engineering projects never go as planned. But I mean, this is why we get paid as engineers, is to figure things out. So I mean, we want to talk about that some. So maybe tell a little bit about the use case. And we can't name names, unfortunately.
Of course, yeah.
But I thought it was really interesting. So tell a little about the use case.
So we're in the process of implementing a solution that will serve to the customers a lot of data in a very quick, reliable way. So what we want to make sure is that our systems have kind of this layer that whenever we need information, we just hit it. So we are looking for a few things. We are looking for availability. We are looking for high performance. And we are making sure that we don't have a single point of failure. And all of that within a microservices approach. So DataStax came into the equation, and we have been working with Alice now for a long time, as I've been mentioning, and we are trying to solve these problems. Now, one of the very interesting things that we have is that we are able to release very, very fast. So that's something that I found quite easy, quite interesting, because we have right now, we started talking about one single problem.
Yeah,
and
the
right
first
now,
use case that we worked
yes,
on.
and now I think that we have to go live with 4 different services across this company that are going to serve different things. So we are talking, for example, about personalization, product data, customer data, even stock. We are not managing stock as the master of stock, but is what is serving us information that what stock we have available.
Wow, we've really narrowed this down to about 1,000 or 2,000 companies now. Yeah, so it seems like it's a pretty common problem with retail, is this sort of thing. So,
yes.
Yeah.
And it helps a lot based on the fact that we are not only storing the data, but also we have the search capabilities. And it's helping us a lot on that because we can start thinking about, this is the information that we have, but how can we expose it? How can we put it out there without actually creating a very complex table models or creating multiple tables? Or how do we make sure that we have all that information multiple times? So it's bringing a lot of benefits to be using the enterprise version.
Yeah, we are balancing between denormalizing for the most used queries and the common query paths, as opposed to creating search indexes to allow this extra flexibility and access in different ways. So it's, for each use case, we're trying to do an analysis as to how the data is going to be used, and that drives, of course, the choice of whether to go with the denormalization or search, and where to mix the two approaches.
So denormalization, I've always felt like there's a little bit of revulsion, like, denormalization. It's going to create a lot of extra data, but you deal with this every day.
Yeah.
And so what is your normal response to the denormalization problem?
Generally, the approach to decide whether to denormalize or not is a consideration on how central that query path is to your application. If you know that you're predictably going to query the data in this way, and you know that you want a really quick, snappy response, you want to be able to retrieve the data immediately, then a native read is the fastest things you can do, of course.
Right. Single partition key, clustering column,
exactly.
one table.
And
right.
and the structuring the key in the right way is really important to make sure that you can cater for these access patterns. When it comes to something that is a combination of criteria, maybe the customer will be able to specify some of these, but not everything, or you can't quite build out all the possible queries that will happen. And that's when you want the flexibility that search gives you.
All right, yeah, that's going to lead into that. So you decided to go with search because you needed an extra layer of flexibility.
Yes.
So maybe describe that a little bit.
Sure. So we have very specific cases where we know, for example, we're talking about customers or product ID. That's just, we there normalize and we make sure that we have all the data that we need.
Yeah.
So that's fine. But there are cases where we are thinking about our sales associates or the people that are in the stores. And we need to have information about what customers do they serve or what are the products that they sell. Things that are not necessarily going to fit in terms of a primary key or partition key clustering columns, where we say we have the information, we don't want to create multiple tables because anyway we need to start extracting that information, and that's when we are deciding to use the search capabilities.
Okay, so now is that embedded in the data model itself, or is it like something that sits on the side? I mean, and I think that's a really common misconception. Is that search is this thing that sits over here, that's near your data, but isn't exactly integrated with your data. And I'm sure you hear the same thing.
Yeah, this is one of the initial discussions that we generally have when we talk about using search and why would you want to go down this approach. Because the idea of having data that is stored natively and accessible natively and also indexed in place, so basically allowing the same data to be accessed in a more flexible way, is radically different to having to maintain a separate indexing cluster.
And this is with SQL syntax.
Exactly.
On top of that,
all of
that's
this
huge.
is done from the same driver with the same syntax, with same SQL language that has got extensions to handle search queries. And this really allows a seamless integration between normal SQL queries, like traditional ones, and search enhanced ones. So that's quite powerful, and I think that's played out quite nicely for the teams. At least working with the teams, it seems like they almost don't make a difference between the two.
Yeah, and I think that that's very important because the teams don't need to get, for good or bad, they don't need to get into the details of how does solar work, how is this happening. They just have the information accessible to themselves. So that's facilitating our ability to develop because they have the information there. We just tell them how they need to use it. And they don't worry about it. They don't need to be aware of those constraints. It's good for them to know, but it enables them to actually get the job done without worrying too much about what technology is in place. So that level of abstraction is very, very useful.
So this is really, I mean, I love the idea of developer experience, making developers more effective so they can build applications faster, less friction.
Yes.
So that's what this is about.
Yeah, without having to switch drivers or switch it between different technologies.
Or to calls to different APIs, all that makes a difference. I think that makes our development faster. So we are, as I was mentioning, we are using microservices approach.
Right.
And we are using serverless approach as well on top of that. So everything is
We've got all those things happening. Yeah.
We have all the buzzwords there, and actually it's working interesting.
But
the important thing is that it's one single function where we can do a retrieve of data without worrying if it's Solar, if it's Cassandra. It's just our driver, and it's providing us the information that we need. So that makes a huge difference.
I think there is also another interesting use case that we're going to look into shortly, which is the store locator.
Oh, now locator, that means
geospatial.
Geospatial, the cool
So of course,
kid.
like you would normally do, you want to go on the site and say, show me the stores in this radius, or potentially you could even want to pan the map and show which stores are there. And these capabilities are supported by search. So it is possible to do that.
Yeah, you're going to learn that. Congratulations. But these are like geometric, so box queries.
Yeah, box queries. If you wanted to, I don't think you're going to get to this level because probably for store locator is not necessary, but you may even want to draw your own polygon. Arbitrarily say, within this shape that I'm drawing, where are the points of interest?
I think I've seen a demo where someone had to draw your own polygon, and I'm like, do I need to reinvent polygons? But it shows off the power, doesn't it?
It's possible. Yeah.
There are some use cases. When I was looking for a house, you need a polygon because you know the area. But in our case, no, we don't.
In your case, it'd be more a matter of radius, probably, or just what is on the visible portion of the map.
Have you ever seen maps for U.S. congressional districts? Those are kind of weird too. But I think that's a different problem. Anyway.
It's just a different side. And maybe when you think about search, you don't necessarily think about geospatial, but that's also one of the capabilities.
Well, and data isn't about a thing sometimes. There's metadata that's so important. It's not just a number, it's not a description, but like a where. And I think today, especially, data is trying to like manifest some global thing, like stores and where they're at, and IoT is all about that. And it's almost this blending of IoT and traditional data models, and how do you sort that out? So it sounds like a really interesting mesh here going on.
I think so, and there's a lot of potential on all the things that we are going to do because we are serving different parts of the business. So they are going to start coming with different needs. So when we start talking about inventory, as boring as it can be, but how we distribute the data and how the capabilities of searching by time, it also becomes very important because now the way that we have modeled our tables, it's going to allow us to very, very easy get stock changes on certain locations and on a given time. So those kind of functionalities are really, really cool.
So I'm going to ask you this because as an Oracle DBA, one of the things I used to run into all the time is people trying to index everything. And then you get into index bloat. So it seems like this is a potential where we would have that. I mean, is that a problem that you
I think they've been really sensible with this, and that's great to see because, you want to index the data that you want to make searchable. You don't need to index everything. You can retrieve all the data that is in the Cassandra table, even if it's not indexed, but you can only search the fields that you've indexed.
What metrics get affected if you over-index? What will happen in your enterprise cluster, DataStax Enterprise cluster? Bad things. Give me some ideas.
More memory consumption, bigger indexes to manage, and also if you index fields that you don't need to index and they change, then that will result in unnecessary index updates. So you need to maintain that. You need the space to basically store the indexing structures, and you don't really get a benefit from it.
Is it really that big of a difference, do you think, sometimes? Is it pronounced, like, oh, wow, you doubled your disk usage?
Depends on the type of the index fields. But in general, the advice is to choose which columns. Of course, you don't need to be super worried. You can index comfortably what you need to. And you can also alter the index later and add other fields to it if you need to. So you can start out with a certain idea and say, okay, we realize that we also need to query and filter on this particular field, so we can add it.
And you're creating indexes using SQL syntax, and now
and also altering it
as well. Okay, because back a long time ago when I first started using the Solar part of DataStax Enterprise, you had to use an XML file. To do that. And
it's no longer the case.
That's great.
That is still possible. The API and the DSC tool is still there, but the recommended way is to go through the SQL APIs.
And create index.
And something quite interesting for us is that we are on the process to automate our whole pipeline. So the fact that we can use SQL queries to do that is allowing us to programmatically do that in a very easy way and propagate it very easy across all environments.
Complaints.
So it actually helps a lot to have that.
So it's built into the schema of your system without having sidecars and other things.
That used to be that's one of the driving reasons behind the change to move this to SQL. So that's been quite exciting.
I think it's interesting. I mean, if you haven't seen DSC Search in a long time, it's probably a good idea to take another look because it has changed a lot.
It's really it's really a powerful technology, and I see it as a way that complements the strengths of Cassandra itself, because when you can do native access, that's brilliant. When you can't necessarily afford that in terms of denormalizing, as we were saying earlier, indexing through search is a really good option to have that flexibility built in.
Okay, all right. So I think this has been really interesting. Roberto, I'd love to have you on again and talk about some of these.
Fantastic.
I mean, we focused on search quite a bit here, but I know you have other things to talk about.
Yes.
And this has been very interesting. And thank you, Alice, for
Thank you very much for having us.
Finally, hearing me. I wanted you to be on this show for so long.
really
You're
cool.
one of the smartest brains out there that no one knows.
I will agree.
Yeah. So we're going to make you famouser and famouser and famouser. And we'll probably see you at DataStax, the Accelerate conference. Huh?
I would imagine so, yeah.
And you too.
That's my plan.
Excellent.
I need to convince my boss.
Got it on camera. All right. Well, thanks everyone. And we'll see you next time.
Thank you.
Cheers.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.